Hello everyone. We are solving question number 52 of GATE 2020 chemical engineering paper related to the subject of process control and instrumentation. The question is, flow of water through an equal percentage valve is 900 liter per hour at 30% opening and 1080 liter per hour at 35% opening. Assume that the pressure drop across the valve remains constant. The flow rate in liter per hour through the valve at 45% opening is dash. So first of all, in this given question, we have been given an equal percentage valve. So if we have to draw this characteristics of this equal percentage valve, we can draw it like this. So let's say if X is my valve opening, that is how much percentage of the valve is being open. Let's say from 0 to 1, where 1 means the valve is 100% opening. Then the fraction of the flow passing through, or the flow capacity, we can call that is f of x. We can plot it as in such a manner. And this flow characteristic, that is the relationship between f of x and x, we can write it by this equation. F of x is equal to alpha raised to x minus 1, where alpha is the constant dependent on the flow. So we will be using this correlation to find the flow rate at any given valve opening. So in the question, we have been given that if flow rate, if F1 is 900 liter per hour, then the valve opening was 30%, that is 0.3. And at X2, that is 35% opening, the flow rate was 1080 liter per hour. That is, we can write this as now in the given question, we have been asked the flow rate at 45% opening. It is at F3 dash. So we can use this correlation where F is the, you can say, the ratio to the maximum flow, and X is the valve opening. So let's put these values in this equation. So if we have to write in terms of this F2 and F1, we can write F2 upon F1 is equal to alpha raised to x2 minus 1 upon alpha raised to x1 minus 1. So F2 we have been given as 1080 upon F1 is 900. Alpha raised to, you can write it as x2 minus x1 minus of x1 plus x1. That is alpha x2 minus x1. Now x2 is 0.35 and x1 is 0.3. That will become alpha raised to 0.35 minus of 0.3 is equal to alpha raised to 0.05 is equal to 1080 upon 900. Now to find the value of alpha, we can take log of this and it will become ln of 1080 divided by 900 will be 1.2 equal to 0.05 times of ln of alpha. That is, the value of ln of alpha will be getting as ln of 1.2 will be 0.1823 divided by 0.05. So that is 3.64. So we will be using this value for our next case. in which we have been asked to find the flow rate at this 45% opening. So the F3 is unknown. Let's take this F2. So F2 is 1080 is equal to, you can write it as alpha raised to x3 minus 1 upon alpha raised to x2 minus 1. That can be written as alpha raised to x3 minus 1 minus of x2 minus plus 1. So from here we will be getting F3 is equal to 1080 into alpha raised to x3 minus x2 x3 is 0.45 and x2 is 0.35. So that is, we can write this as alpha raised to 0.1. Now we need to take log of this to find the value of, no, so from over here we can simply calculate the value of alpha and put it here. So this will give us alpha, value of alpha as 38.09. So 1080 into 38.09 raised to 0.1. So it will be 1.43 into 1080. 38.09 raised to, so this will, you can approximately write this as F3 is equal to 1555. So the final answer, that is the flow rate through the valve at 45% opening, we can write it as 1555.